Well, hi there. So in this video, we're going to take a look at trade. And what we mean by that is when is it good for countries and individual people to trade with each other and under what terms? Like what would be a good deal? We're going to start with production possibilities curves and move into trade analysis. Let's get started. So to start us off, we're going to talk about a little bit about trade. Trade just means a mutually beneficial exchange. So it's kind of what you'd expect that we both actually benefit from it. There's no coercion or anything like that. There's two words or phrases that we need to be able to understand with relation to trade. One is absolute advantage. This just means that given the same amount of inputs, which is like time and resources, right, that one person could do more of something than another. So one person can produce more output. Another way to think about that is actually that I could produce one unit with fewer inputs. That's another way to think about absolute advantage, that it takes me maybe less time to do one thing than it takes you. So for example, you think about me, Gloss, and Usain Bolt, one of the fastest people who ever lived. Well, Usain Bolt is faster at running the 100 meters than Gloss. So he has absolute advantage in running 100 meters compared to me. If we were to translate that into, say, cutting the grass, well, Usain Bolt can cut more lawns than I could in the same amount of time with the same lawnmower. That's what absolute advantage means. Unfortunately, even though it's really easy to wrap your head around, it's completely useless for knowing what we should be doing, because I virtually guarantee that Usain Bolt does not cut his own grass. And that's because Usain Bolt and a whole lot of other people understand the idea of comparative advantage. This means that you have a lower opportunity cost of producing something given the same inputs. In other words, it doesn't mean that you can make more of it. It means that you give up less to make it. And that is actually the thing that you should do. You should produce that thing. So if you're wondering, like, what should I do with my life? What? Like that, there's an answer right there. Figure out what's the thing that you do where you give up the least amount to do it, because that's what you have comparative advantage in doing. It means that you're really, really good at producing that particular thing given the same amount of inputs, that you have a lower cost of producing it. It's a little bit harder to wrap your head around, but we'll take a look at it in just a moment. Now, you can't actually have comparative advantage in producing both of the two goods that we will talk about. So for example, if you make pizzas and burritos, you can't actually have comparative advantage in both. It's impossible mathematically. We'll see that in a second. Whichever one, as I said a moment ago, whichever one has comparative advantage, that's what they should produce. They should sell it. The other one should buy it. And conversely, the other one should produce the other thing, because mathematically, they actually will have comparative advantage in the other thing. It's very simple. You either have it in this or that, or you have it in that or this, and the other guy should do the other thing. Now, the seller's opportunity cost, the one who has the comparative advantage, their cost of doing it is actually the lowest price that they're willing to accept for selling it to someone else. We're going to look at that in a moment. The buyer has an opportunity cost of doing it themselves as well. That's the maximum price that they're going to be willing to trade at. This is going to become more clear once we actually get what those numbers look like. But if you remember from the previous video, we calculated what were the number of baseballs that were the opportunity cost of making a helmet for one country. Well, that opportunity cost number, the two baseballs that we calculated in the last video, that's the price, right? That's what the seller price or that's what the buyer price would be. That's their maximum or their minimum price. Now, from PPCs to comparative advantage, let's kind of take this stepwise. This is the first type of problem we're likely to see. It's called an output problem. We'll come back later and talk more about later what that means. But first, we just look at it. So Mexico and Italy, they could make 10 pizzas. Both could make 10 pizzas. And Mexico could make 30 burritos. Italy could make 20. We're going to take these numbers and then we're going to put them into a table, right, called a comparative advantage table. And it's set up thusly. You have the two countries on the left, or the two companies, or the two people, if you're talking about two individuals. And then you have the two goods on the columns. So you have burritos, and you have pizzas. Now, in the box here, we're going to put the maximum amount that they could make. So they could make 30 burritos and Italy could make 20. And they both could make 10 pizzas. Now, the way we calculate opportunity cost is we take the other item and we divide our current item by it. The outside number goes over the inside number. So we can see here, if we're talking about one burrito, what's the cost for Mexico to make one burrito? Well, we take this outside number 10, and we put it over 30, and we find that one burrito for Mexico costs them 1/3 of a pizza. It's a little hard to think about, but let's do the other side. One pizza equals, so what's the opportunity cost of a pizza for Mexico? We take the outside number, 30, over the inside number, 10, and we find that it is 3 burritos. So the opportunity cost of of Mexico making one pizza is 3 burritos. And it's reciprocal, right? They should be because it's mathematically the same relationship. By the way, an aside here, you can only do this with constant opportunity costs. So that's kind of nice, right? You'll never get these types of questions where there's that bowed out thing. It doesn't work. Now, Italy, let's do theirs. 1 burrito for Italy. And I'm going to start abbreviating 1B equals, take the outside number 10 over the inside number 20. 10 over 20 is 1/2 of a pizza. And then we say, well, what's one pizza? And how do I know that I'm doing this in the right column? Well, this is the burrito column, 1 burrito. This is the pizza column, 1 pizza. And then I take the outside, the 20 over the 10. That's equal to 2 burritos. Burritos. So I've filled out my table here. Now I circle the box showing comparative advantage. Now this part is a little bit tricky if you don't remember what comparative advantage is. So comparative advantage, let's go back up, having lower opportunity cost, right? So whichever one has the lower opportunity cost is the one that should produce that. So who has the lower opportunity cost of making a burrito? 1/2, 1/3? Well, clearly 1/3 is smaller than 1/2. So we're going to circle this. That means Mexico has comparative advantage making burritos. Who has the lower opportunity cost of making one pizza? Who gives up fewer burritos to make a pizza? Well, that's going to be Italy. So Italy has comparative advantage in making pizzas. Mexico has it in burritos. Now we can answer some of these other questions. Who's the seller? Well, the seller is the one who has the comparative advantage. Who has the comparative advantage in burritos? We circled it, Mexico. Right? And it's not asking us for why. We'll just got to say that Mexico does it. What's the seller's minimum price for a burrito? So Mexico's the seller. What's the lowest price they're going to take? 1/3 of a pizza. It's just that easy, folks. Just that easy. 1/3 pizza. Now, we talked about on the other side for just a second here. Who's the seller of the pizzas? Well, Italy, because they have comparative advantage in it. How do I know what Italy's minimum price they're going to take for one of their pizzas is? 2 burritos. What's the maximum price that Mexico will pay for a pizza? Because remember, Mexico's buying the pizza. The maximum price that they're going to pay for their one pizza is 3 burritos. So actually, this is the minimum. That's the maximum. 2 burritos, 3 burritos. What's the maximum price that Italy would pay for a burrito? Well, maximum price that Italy would pay for a burrito, 1/2 of a pizza, right? So these numbers, these opportunity cost numbers that we're calculating are just minimum and maximums. How do I know which one's the minimum? It's the smaller number. What about the maximum price? It's the bigger number. So they're really not that bad, right? Now let's try the second type of problem. I didn't really talk about that there are 2 types here. I just said the first one's an output problem. In an output problem, you take the outside number over the inside number, right? The second type of problem is called an input problem. They're relatively easy. There's just one tweak that we have to make. An input problem, they don't tell you how many burritos and pizzas you could make. They tell you how many inputs it takes to make one of them. So the really tricky part is just knowing how to recognize them. If they talk to you about how much time to make a burrito, how many workers to make a burrito, all that kind of stuff, that's how many inputs to make one. And that tells us it's an input style problem. The only change we're going to make with input problems, we take the inside number over the outside number. For output problems, we take the outside number over the inside number. I'll say it like 3 times fast. Output problems, outside number over. Input problems, inside number over. Output problems, outside number over. Inside problem, or input, oh man, see, I can't even say it 3 times fast. Okay, moving on. Calculate the opportunity cost. 1 burrito equals 1/3 of a pizza. And notice I took the 5 over the 15. Let's do 1 burrito here. Inside number, 30 over 15. 30 over 15 is 2 pizza. Right? 2 pizza. And then let's do over here 1 pizza, inside number 15 over 5. 15 over 5 is 3 burrito. And 1 pizza here, inside number over 15 over 30 is 1/2 of a burrito. And so these are different opportunity costs, right? But let's take a look. So what would be the lower opportunity cost of making a burrito? Well, now it's still Mexico, because 1/3 is smaller than 2. And on this one, who has the lower opportunity cost of making a pizza? Well, it's going to be Italy, because 1/2 is smaller than 3. Now, it may not always correspond to who has absolute advantage. So this is a good time for us to just kind of quickly refresh, where's the absolute advantage? Well, Mexico has absolute advantage in burritos because 30 is bigger than 20. They also have comparative advantage. It just happens to be a coincidence. Neither of them has absolute advantage in making pizzas because 10 equals 10. But you can still have comparative advantage even if neither party has absolute. For the bottom table, notice 5 and 30. Well, who can make a burrito faster? That's Mexico. So they have absolute advantage in making burritos. But in terms of pizzas, again, we have a tie. It takes them the same amount of time, so neither one has absolute advantage in making a pizza. But that doesn't mean that they should just split the difference. Italy should go all in on making pizzas. Mexico should go all in on making burritos, and then they should trade for however much they want of the other thing. If they do that, they can actually consume more, both of them together. They can consume more than if they just did it themselves. That's the magic of trade. So the last part on here, who's the buyer of the pizzas? So let's take a look in the pizza column. Well, we know that Italy is the seller because they have the comparative advantage. So that makes Mexico the buyer. And what's Mexico's maximum price? Well, 3 burritos. Just that easy. Hopefully this helped you. I'll see you next time.